All right, thank you so much for having me out here, and thank you for voting for my talk. I know I left it very vague when I created the talk, so thank you for voting for me. Deploying Wi-Fi in harsh environments. So what does that mean exactly? So by itself, it could mean anything. So let me give you a clue here. I'll just have to turn this on here. Yeah, so it's a warehouse. So what's so harsh about a warehouse? Let me give you the next clue, which doesn't seem to work, but sorry. Industrial freezer edition, sorry about that. So what we're seeing here is deploying Wi-Fi in industrial freezers where they do food storage. In these types of environments, you're dealing with extreme temperatures as low as negative 20 degrees Celsius. What people don't realize about that is even with your protective gear on, your breathing does become a little more difficult. Your body exudes more energy trying to warm up the air. You actually do exert a lot of energy in those particular environments. It is pretty harsh. You're definitely going to feel it. It is very cold. Your scissor lift battery life will be reduced by about 50 to 70%. So you do need to have spare scissor lifts when you're working. Thermal gloves reduce dexterity, so when you're trying to crimp cables and that sort of thing, it can be problematic. It does increase your installation time significantly. Looking at some physical characteristics, you do see a lot of frost in these cold environments. It's very important to determine where you're going to place your access points to be able to locate areas where the temperature fluctuates and you get a lot of humidity coming in and out. This can actually be region specific. So if you're in areas that are high humidity, you're going to see a lot of more that. That's a doorway there, and going in and out of the docks areas is a problem. You do also have product that will be all the way up to the ceiling. You have specific tunnels. In environments like this, rack space is very important. So your client is going to be particular about where you can put access points. You got to look where forklifts are going to be going. Make sure that you're not going to get one of your access points hit. Even on the ceiling, you have very little space to work with. Some more physical characteristics. Deep racking means that RF will penetrate not as well, so you have to look at using directional antennas. And this is another example of product being stacked pretty much at the ceiling level, so you got to be very cautious of that. Cold impact on hardware. A lot of people don't realize this, but cables will actually freeze and break if they're not rated for this particular cold environment. Your access points should be tested to withstand these temperatures. In our particular case, we did a what's called a cold soak test, placing multiple APs in negative 40 degrees Celsius for multiple hours. What you do after that point is you turn it on and make sure devices can connect to it and it works properly going forward. Cutover challenges. Many sites are operational specific. They're 24/7, 24/6, 24/5. You have very limited time to do the cutover. You have to make sure that 200 or so meter devices or your networking devices are in place and operational, as well as 10 to 20 of the customer critical systems. This includes alarms, security cameras, those sorts of things. Very little time window, between about 8 to 12 hours to complete the whole process. Design strategy. For our particular purposes, we did use pre-assembled backboards. This reduces the installer's time inside the warehouse and makes it very specific of what they need to do. We set the angle before time. We set the AP number, and we just point on a map and say that you can install this at this height. We created different backboard solutions. This is a predictive of the dock area. Inside here, we actually installed them on the walls. The reason being is because, for two reasons. The pallet positions with pallets coming in and out of the dock, you may not get an opportunity to put something on the ceiling because there's going to be a bunch of pallets in your way. So you have to choose a position which actually is not going to be used that much. A lot of those times it's in front of an exit door or in front of the actual docking load door. Docking load door is going to get used more often, so exit door is a better position. This also allows RF to penetrate into the actual trailer beds when you need that, and we also have access points outside. Aisle freezer center. This is an actual survey data using Romigh. This is our meter access point, and the center of that aisle, you have to make sure that it is right at that right angle so that any air blowers or anything is not going to disrupt that signal. You also need to make sure that it's in a position where it won't get hit by a forklift. In some cases, you can't install something on the ceiling, so you need to do end-of-aisle coverage. This is another Romigh survey here of an example of end coverage. Now you see it hits right there at the end. That's where we get to end cap coverage. A lot of people don't, vendors or something, when they're putting in access points, don't think about what happens at the end of that aisle. What happens when the truck turns that corner? They're going to either lose connection or they're going to try to connect to the next AP on the next aisle, and that can cause a bad experience. So you want to make sure that they can hang on to an access point all along that edge. Tunnel coverage is very important for the same exact reason. This is a predictive model here, but you'll see the AP in the corner. We had to think of a creative solution to make that happen. We ended up installing them with beam clamps. Here's the actual survey information. Predictive model does not equal what actually you see in the field, so you need to make sure that you're measuring this accordingly. Thankfully, I put 2 APs, one on each corner of that tunnel, and make sure that we have coverage all down. There's a close shot of the AP right above that rack in that tunnel. And just testing it real quick to make sure that the forklift clears that. It looks like it did by about 10 inches or so. Got a couple minutes here. Last but not least, know your devices. Make sure you know what you're deploying for. Make sure it has the adequate power and adequate gain to be able to work with your antennas. It's enough to make sure that you have coverage down an aisle. It's another thing to make sure that your clients can actually get back accordingly. So you want to make sure that your clients are able to work in these environments. What hasn't been covered here today is all of the strategic things involved, 4 to 6 weeks of installation coordination with installers on site, site coordination, site surveys afterwards, equipment and client inventory. When you're trying to cut over a warehouse, you want to do it effectively. You want to make sure that everything's accounted for. You have an inventory list of what needs to come online on the network, and you're making sure that it all comes out smoothly. Key takeaways: dress warm. You're going to feel it. It is very cold. Test your equipment, make sure it can work in those environments. I know we did a pretty thorough test here, but sometimes it's not accounted for that actual access point is going to boot up after it's been in a cold environment off for a very long time, or it may behave differently than you expected. Design with intent. It's a term I like to use. That's using directional antennas. You don't have to worry necessarily about penetration through racking space if you're designing with coverage in every aisle accordingly. Know your devices, like I was just talking about. Know what devices you're deploying and make sure you plan accordingly. And last of all, be safe. It is a very strenuous environment, and accidents do happen, but all right, I want to thank Samuel Clemens and the entire Meter team for doing an amazing job for these 5 last deployments. I actually was at a deployment on Saturday right before I flew here. Thank you very much.